Welcome to my presentation. This presentation is part of the playlist Integrals of Logarithmic Functions. In this video presentation, we will be explaining examples related to logarithmic functions. Let us look at some examples. Let us evaluate this integral. Integral 5 divided by e to the power of minus 5x plus 7 dx. Before we solve this example problem, we're going to simplify the given example problem as shown here. 5 divided by e to the power of minus 5x plus 7 can be written as 5 divided by 1 over e to the power of 5x plus 7. So I've brought this, when we bring the negative exponent to the denominator, it becomes a positive exponent as shown here, 1 over e to the power of 5x plus 7. So the common denominator is e to the power of 5x, and in the numerator we will have 1 plus 7 times e to the power of 5x, 5 divided by this whole expression here. So when we simplify it some more, the e to the power of 5x in the denominator comes to the numerator. So 5e to the power of 5x divided by 1 plus 7 e to the power of 5x is what we have as a simplified example problem. Now we can solve this example problem. So when we solve this example problem, this is how it's going to look like. We're going to use the logarithmic rule to solve this example problem. So we're going to substitute u as equal to 1 plus 7 e to the power of 5x, and that is what we have in the denominator. Since u is a function of x, we're going to differentiate this function with respect to x. Du by dx is going to be equal to 7 times 5 e to the power of 5x. So d by dx of 1 is 0. d by dx of 7e to the power of 5x is going to be equal to 7 is a constant, so that is what I have here, times 5 is e to the power of 5x. So it's going to be 5 e to the power of 5x. So therefore, we can then write this as 7 times 5 is equal to 35 e to the power of 5x dx. So I brought this dx to the side of the expression here. So we can, if we have to express it in terms of dx, we can write it as dx is equal to 1 over 35 e to the power of 5x du. Now we can substitute u as equal to 1 plus 7 e to the power of 5x and dx as equal to 1 over 35 e to the power of 5x du, like that. And then we can substitute these into our given example problem, use the rules of integration, and then solve this problem. So our given problem is integral 5e to the power of 5x divided by 1 plus 7 e to the power of 5x dx. So 5e to the power of 5x is the same. Instead of 1 plus 7e to the power of 5x, we're going to write it as u. We're going to substitute it as u, as shown here. And then instead of dx, we're going to write 1 over 3 to the 35 e to the power of 5x du. So we have successfully substituted all the values in here. Now we need to simplify. As we can see here, e to the power of 5x is in the numerator, e to the power of 5x is in the denominator. Those terms cancel out. So we have a 5 in the numerator, 35 in the denominator. 35 is the multiples of 5. So 7 times 5 is 35. So 1 over 7 is what we can pull out as constant outside of the integral symbol. So we are left with 1 over u du. So we know that according to the rule, integral 1 over u du translates into ln of u. So therefore, we can write this as 1 over 7 ln of u plus c. As we mentioned before, we need to express our solution in terms of x, not in terms of u. So we started to say that let u be equal to 1 plus 7 e to the power of 5x. So wherever we see u, we're going to substitute 1 plus 7 e to the power of 5x. So therefore, we can write this as this step as follows: 1 over 7 ln of 1 plus 7 e to the power of 5x plus c, where c is the constant of integration. So this is the way we're going to solve example problems related to logarithmic functions. Let's look at another example. Let's say this time we want to evaluate a function integral x divided by square root of x squared plus 1 dx. We're going to use the logarithmic rule to solve this example problem. So we're going to substitute u as equal to x squared plus 1. We have x squared plus 1 in the denominator, but that has a radical term on it. But we are going to substitute u as equal to x squared plus 1. Since u is a function of x, we can differentiate this function with respect to x, as shown here. Du by dx is equal to 2x. So as you can see here, d by dx of x squared is 2x to the power of 2 minus 1, or 2x. D by dx of 1 is 0, so we need not have to write that. So therefore, du by dx is equal to 2x. We can also express it as du is equal to 2x times dx. So we brought this dx to the side of this expression here. And if we have to express it in terms of dx, we can write it as dx is equal to 1 over 2x du, as shown here. Now we can substitute u as equal to x squared plus 1 and then dx as 1 over 2x du into the given example problem, and then use the rules of integration and then solve this problem. So our example problem is integral 1 over square root of x squared plus 1 dx, right? Now wherever we see x squared plus 1, we're going to replace it by u. So since x squared plus 1 is under the radical term, we're going to put a radical term over u as shown here. X divided by square root of u, and then dx we said is we're going to write as 1 over 2x du. So that's what we did here, 1 over 2x du. And therefore now we're going to simplify it. We have an x in the numerator, we have an x in the denominator. Those two terms cancel out. So we are left with 1 over 2, let me write this here. Integral 1 over square root of u times 1 over 2 du. So since 1 over 2 is a constant, so we're going to pull that out of the integration process. So 1 over 2 integral, what we're left with here is 1 over square root of u du. Excuse me. We know that integral 1 over square root of u du is equal to ln of square root of u, like that, plus c. So when we put everything together, it reads as follows: 1 over 2 ln of square root of u plus c. As we mentioned before, wherever we see u, we're going to replace it by x squared plus 1, and therefore we're going to rewrite this step as shown here: 1 over 2 ln of square root of x squared plus 1 plus c, where c is a constant of integration. This is the way we're going to solve example problems which involve logarithmic functions. In my next video presentation, we will be solving more example problems related to logarithmic functions.